Hello, this is Eric Miscoll with EMSNOW here at IPC APEX 2020 in San Diego. We have Indium with us today. Chris with Indium is here. Chris, thanks for joining. Always good to talk to you guys because as we were saying before, I was saying to you before, you guys really are, you're involved in everything. It's solder, it's the glue of the industry, right? It's what should make everything work, right?
Well, I think, you're right. It does give us an opportunity to get involved with a lot of the new technology trends, and we do that's one of our strengths, is we like to be involved with emerging technologies and really give the industry some really unique solutions. So
there's two in particular we'll talk about today, kind of the high reliability kind of applications that you have. The first one being the DuraFuse, and DuraFuse is really for, well, explain how that works. We were talking about it before, and I won't do as well or eloquent a job as you will on this one.
Okay, so DuraFuse LT is a low to mid temp solution, and the industry is looking for low temp solutions right now. There's probably three important drivers. One, there are certain components that can warp at higher temperatures, so by reducing the reflow temperatures down to lower temperatures, they don't potato chip as much or warp as much, so you don't get the defects you do like non-wet opens and things like that. That's one big driver. One that's kind of unique is if you can source lower cost components that aren't rated at 260 but rated at maybe 210 or 220, and the same with the board materials, there's the opportunity to save lots of money there by having a low temp solution. I think that's really an awesome opportunity. And then there's also applications for step soldering, where you do the SAC 305 soldering first and you follow it with a lower temp later. So those are kind of the three main ones. There might be some others, but major ones.
Are there particular industries that's most applicable to?
Yeah, well, it could be multiple ones. I don't think we know yet.
Okay.
I think that the conventional low temp solutions we've had in the industry have really restricted the thinking on where it could go, because the low temp materials are all bismuth rich alloys. They're based upon the bismuth tin or bismuth tin silver with some type of dopants. They're all based upon bismuth rich solutions. And all those solutions are very brittle, have horrendous drop shock performance. I mean, one drop. Now there's some applications you don't drop, but you do have to ship them, and people are concerned about that. Even when you're making the boards themselves, when you're doing the PCB assembly, just an operator who might, torque the board a little bit it's so brittle those could break the solder joints. Okay. So all those things have really restricted the applications. Now with the DuraFuse, you've kind of opened the door for a broader range of low temp options. So I think we'll leave it to the industry to figure out where it goes.
And that's interesting on the cost saving angle, so to speak, but materials is the largest percentage of the cost of boards, right? It's not the labor. Everybody focused on that. We've beaten that into submission. So focusing more on if there is an ability to substitute at lower cost, parts, that should be of interest to the industry.
I think theoretically it's a great opportunity. We'll see how things evolve.
So let's move to the other one, the Indium 292. Is that the one?
Indium 292 is our Hi-Rel alloy. This is more oriented toward the automotive markets and some of the the tougher LED applications. And there, they do pretty strenuous thermal cycling. And that's where, the industry's push, I think Inalot was probably the first solution to that problem. And you're looking at thermal cycling like minus 40 to 125. So we're really focused on minus 40 to 150. We're kind of looking at the new applications coming on. So we're trying to find good solutions for that space. And we're also, the Inalot was kind of limited by it's had a weird patent and royalty arrangement where only 3 companies could get to those. And it gave some restrictions to the market. So we've come up with a solution which is outside that patent range and you can operate in. So that's something we really like about the Indium 292.
And now I saw in the marketing that it also is a good-looking solder. There was something removing the pinholes. What was that?
Well, that's true. Yeah. You did your homework.
A little bit.
I'm impressed. Yeah, if you look under a microscope very closely, you look at the surface and how smooth it is. You could get little pinholes in it. It's a disturbed surface. So we see that this alloy actually provides a smoother surface with less of those cosmetic defects, which really just make the solder joint not look as good. But the other benefit to this alloy is when you do we're focused on minus 140 to 150, we get the targeted number of thermal cycles that they're looking for. And also when you examine the joints, when you do examine the cracks, the crack length is shorter. So this is another nuance that people are very, very focused on this type of reliability and performance. The crack length and ratio is very important to them. So that's something we see an important difference there.
It's interesting. When I was in graduate school, I had a professor used to always say on the papers, get it right and then make it pretty, right? So it sounds as first you got it right and it actually looks good too. So
there you go.
An important aspect.
There you go.
Yeah.
It's a handsome solder.
We should have an award for that, right?
There you go.
We'll talk to Circuits Assembly for their SEAs. But, well, listen, I appreciate taking the time today. As always, we spoke last year and this year again. Maybe in the fall we catch up again. Maybe there's some new trends and some new things happening.
I hope to have something for you.
I hope you do.
Thank you.
Appreciate it. Thank you, sir.